cooperative project between IRD and his partner in South America and now also in Mexico. We start last year to work with Ligia and some colleagues from Instituto de Geofísica and also from the Institute of Marine Science and Limnology. And I apologize if I will do some mistakes between language because I speak Arabic, French, Portuguese, Spanish, and English, but sometimes we will earn some Arabic words. I will apologize. And today I will present a work about the climate change in South America. And I focused of the 2,000 years because I think that is a good Windows time to understand very well the very natural variability of climate change and to try to propose some future scenarios prediction in this region. I think that all of you know these famous papers published by Hugh and Peterson et al. On Cariaco Basin, then use some proxies about to reconstruct precipitation and heterogeneous input using titanium concentration marine sediments. And they do some calibration. Here we have 3 graphs. Variation of precipitation during the year, when we know that during summer period we have more precipitation in this region, principally in Venezuela, and also the rivers transport with totally linked to precipitation, then we have runoff and transportation of material from the continent to the ocean. Then they made some works on sediment trap to collect the material in the sediment trap, and they showed they had interannual variability of the heterogeneous impact, the heterogeneous input in the marine sediment that they interpret by the variation of precipitation in the continental. Then they took some marine cores, they dated, and they follow the variability of the titanium, this region, and here we can reconstruct really the amount of precipitation and automatically dry season versus wet season during 2000 years. They interpret, for example, for this period, like Little Ice Age, dated from 300 years to 100 years. They interpret this period by dry phases linked to displacement of the ITCZ to south. This is the first paper published in 2006. They start to interpret this variability like the displacement of the ITCZ from the south or from the north. When they have high concentration of titanium in the basin, they interpret that from increase of precipitation to heterogeneous transport and then humid conditions. And in 2008, I start a long stay in Brazil, and we decide with some friends and some colleagues to work in this period for 2 reasons. The first one, here is the report of GIEC, it's like IPCC report, and they show that all studies concerning the study to 2000 years is focused principally in the North Hemisphere and nothing in the South Hemisphere. Then we try to work in this period and to work in different archives, natural archives, to see how the climate was during this period. And also, you know this report that it is the variation of the temperature in the North Hemisphere, and you follow the same period like Little Ice Age, which is colder than the MCA, medieval climate anomaly, which is more warmer this period. And we decide to work in South America to show how the climate was during this two period. And during my conference, I will present all studies that we made this period linked to this period principally. And also in 2009, Mann et al. Published a paper where he compared various different proxies, for example, for Peru, using marine sediments from north of Europe, from some set, but really few sites. And he concluded that during the 2000 years, the climate variety in South America and also in other regions is characterized by increase of La Nina conditions during the MCA and El Nino conditions in the LEA. A new interpretation, because Peterson have interpreted this change like the displacement, seasonal displacement of the ITCZ, and Mann propose that this climate is more controlled by the interannual and also multidecadal variability during the two periods. And when we start to work in South America, we use different archives. We use marine sediments here, principally in Peru, Chile, and also in Brazil. We use stalagmites, paleothems, in all of South America, in Peru, Bolivia, and also in Brazil. And you used coral because we are interested to reconstruct the ICST, the sea surface temperature variability, and to say some variability of the oceans, some variability of the hydroclimate variability in the continent, and to compare them and to see how the climates, which mechanism control the precipitation in South America. And we compare our results with all works made in Chile on ice cores and also on tree rings. And the first work that we published is a work of our doctoral student, Salvatore Chieta, who is Peruvian. Today he's working in Germany. And we were interested to look how the Humboldt system was varied during this time. And we took different marine sediment in Peru, in the continental shelf of Peru, and we can show the kind of marine laminated sediment that we took. And we used a lot of proxies to reconstruct different conditions of the oceanographic things. First of all, we used total organic carbon to reconstruct the total exportation production of the carbon in the systems. We also used the elemental markers of redox conditions, and also we used some markers of the oxygen minimum zone, like nitrogen 15. We can reconstruct, trace all mechanisms linked to the expansion or reduction of the oxygen minimum zone, whose characteristics of the ocean in this region. And we compare our results with some results from the Indo-Pacific region and also from the Galapagos. I can't show in details our work, but I will underline two periods. The first period, it's the MCA, which is the medieval climate anomaly, dated from 1100 years to 900 years. And we can show in this period we have high productivity systems. We have also anoxic conditions that also underlined by the ratio between molybdenum and rhenium, because the molybdenum and rhenium can reconstruct the condition of the anoxic and also in the water column, but under the sediments. And we can show also that the nitrogen 15 marks a very intense oxygen minimum zone during this period. And also we have some results that show that the South Pacific high is expanded more to South America. And all these results show that this period is linked to high production, intense OMZ, and little transport to the continent. Comparing with the LEA, we can show opposite conditions: low production and low export carbon, organic carbon to the sediments, more suboxic conditions, underlined by the rhenium molybdenum ratio and also by the values of the 1915 during this period. And when we compare our results with the Indo-Pacific region, we can show here that the difference temperature between Indo-Pacific region and the equatorial region, we can show really high differences between these two periods, which means that the system is more warm, warmer here and colder here. And this is the paper published by Clements, explaining that the theoretical mechanism of the thermostat mechanism. When we have a big difference temperature between two regions, we can really intense the transport from the equatorial Pacific region to the West Pacific regions. And then we was interested, based on these results, to follow how the winds has changed during this period. And we start with the PhD students from Colombia to work and to reconstruct variability of the wind transport. Then we used principally the green size element to reconstruct the velocity of different kind of winds. Also, we are interested in two periods. We can show here high aeolian transport during this period and low aeolian transport accompanied by low double peak of fluvial transport marked by this green size element of mineral fractions. And during the LEA, we have more fluvial transport than aeolian transport. And after 1800, the aeolian transport increased again. And we compared our proxies of the wind transport with the geochemical markers like molybdenum and radium. You can show during the MCA, this high wind transport can favorize the upwelling, coastal upwelling system, favorizing the productivity. And during the LEA, we have more fluvial transport linked to the ITCZ shift to south. And then the aeolian transport was really weakened. And the system back to the normal conditions during the current warm period. And for that, we propose a scenario that based on our geochemical and sedimentological process, that during the MCA, we have ITCZ shift to north, which allow intensification of the South Pacific high, favoring the increase of the upwelling intensity. And during the LEA, we have a south shift, the ITCZ more south, declining of the South Pacific high in this region, which explain the weaker production in the systems. This is the framework of our work in the South Pacific, in the Peruvian systems. And then we compare all these things with the hydroclimatic variability in the continent. And we based our study in the oxygen isotope of the speleothems, principally in stalagmite. And we worked in different sites in the Peruvian region, and we compared them with other sites in the Brazil. And here we have oxygen isotope variability here in this site of Peru, comparing with the AMIO Atlantic multi-decadal oscillation, we can show in the MCA, in this region, we have a little fractioning of the isotope which marks dry seasons. And during the LEA, we have really intensification of the monsoon marked by high values of the oxygen isotope. Two interpretation, MCA is in Amazon region drier than during the ICA, and the LEA is characterized by the increase of precipitation around the 30% comparing to today. And required that here in the MCA we find La Nina events, and La Nina event impact the basin of Amazon basin on arid zones and the dry seasons. And here we have intensification of the monsoon during the LEA. Two opposite climate conditions. Then also, this work is published on Pal in 2008, made by a group of researchers from Peru, Bolivia, and IRD, and they worked of the advance of recall of the glacial, principally in Peru and Bolivia, and we show here from the isotope markers of the Calcaya ice cores that the tendency of this glacier is to reduce during the current warm period and advance it during the late ice age. Compared at the regional scale, we can show really high advance of the glacial during the beginning of the current warm period and retrieving during the last 50 years. And this paper we published this year in the Scientific Report of Nature Communication. We used two proxies, a proxies made in biomarkers in organic sediment markers in lichen sediment, and also we used the atoms to reconstruct the lake level change. And we compare them, like for example, the titanium in the region. And we can show really when the lake level increase here is linked to the advance of dunes during drier seasons. When you have dry season in northeast Brazil, these dune events blocked some valleys and allow the high lake level. And using the proxies, we can interpret that like humid conditions, but not. When you use biomarkers, delta deuterium in organic matter, we can see here really values that show to us that the climate was drier. Drier climate in this period allow dune advanced and allow high lake level. And this we will interpret like principally linked to the variability of the Atlantic SST in this basin. This is a paper published by a group of USP in 2014. They show that the Atlantic variability, like the Atlantic multi-decadal oscillation, control very well the transport of the humidity from the Atlantic, tropical Atlantic, to the South America. In this configuration, when we have more high anomaly temperature in the Atlantic, we can show there's a precipitation in intensification of the monsoon, allowing a lot of precipitation in the Amazon region and also in the southeastern part of Brazil, and ITCZ is here, for example. When we change these conditions with more higher temperature in the South Atlantic, we change completely the transport of the humidity to the South America, allowing more transport to the Argentina and the Argentina basin, with total decrease of precipitation Amazon region and surrounding Brazil, and also a high development of the ITCZ in this region. And we explain this scenario, this change, linked principally to the change in the Atlantic variability. And we used also some historical data to, because our records don't allow to work on high resolution. And we worked of historical data from the Northeast Brazil using a lot of documents. And we can show here because precipitation in this zone with more precipitation to the north of northern Brazil with low precipitation in the Bahia region. And we used a lot of documents and we did composite constructions. And this composite was made by the researcher from IRD, name is Luc Ortlieb. He's died, it's a friend died since 2 years ago. And he comparing the South American documents with Peruvian Ecuador, Central Chile and Brazil, and make this interpretation that the dry season in this region was completely synchronous between in South America from 1800 years. Before, we can't show any concordance between all these regions. And he conclude that it's only from 1870 onward that the ENSO anomaly rainfall have the same anomalous region in northeast Peru, Brazil, central Chile, and well correlated with the Brazilian, which means that the actual manifestation of the El Nino start principally from the 18th. And it's really complex, the climate variability in South America. And if you interpret also that the South America is linked or is dominated by the variability of the ITC is also monsoon region, it's not correct. It's wrong because there are a lot of things to make it to take in advantage. And to know how the climate was more south in South America, we worked on the site in Bolivian region using speleothems. And here is our records based on oxygen isotopes in speleothems. More negative values is linked with season and more less values linked to dry season. And if we compare our records with other records to Brazil, we can show there is anti-phasing, anti-phases, because when we record here more wet season, the northeast Brazil is dry. We show really that the climate variability in South America, it's not only controlled by the shift of the ITCZ or the intensification monsoon, but there is other processes controlling these systems. And we try deeply to interpret this variability, and you use this scenario again that I can explain here. Sorry. And we show that the MCA is really controlled, is really dry in this region. That I show to you using the speleothems from Peru, and link it more with more precipitation in this region. And the opposite phase is the development during the LEA. More precipitation in the Amazon basin and less precipitation in Amazonian dry precipitation in the northeast Brazil. And to explain that, there's a paper published by Espinosa, who is a climatologist from Peru, working with the climatology. And he explained this mechanism. Sometime within the internal annual variability, we have interplay between the Indo-Pacific region and the Atlantic. This development of the PDO or EPO conditions allow high temperatures in the South Atlantic basin, allowing the transport of the humidity from the south of the Atlantic into the South America, then from the Atlantic. For this reason, we have dry phases in Amazon region and a lot of precipitation in the Bolivian system, which explain the high precipitation occurred during 2014. For that, we, after to use all the reconstruction based on proxies, on observation, we decide to go to the models. And first of all, we worked of the stations, on meteorological stations in South America, and to try to know, using statistical methods, how the which mechanism control the precipitation in the all South American, principally in Amazonian region. And we know we observed that the precipitation follow a multi-decadal variability during the from 19th to 2005, using only observed results from the meteorological station. And it's important think that crossing all this data with the global indices, we show that this variability is controlled by the interplay between the Atlantic variability and the Pacific variability, working together. And sometimes they fight, and one of them win, maybe the Atlantic, maybe the Pacific, which explain this kind of variability, and which is more important, we can show here an anti-phasing between the Northeast Brazil and Western East Brazil. Principally, lower precipitation in this region and more precipitation in depends of the periods. And then we based to reconstruct this variability during the 2000 years, we compare this GPCC instrumental data, which is in red, with oxygen isotope recorded in lacustrine sediment in high variability, because Pumacocha is a high laminated lake, contain more carbonates. And using this carbonate, this record, we can show really a very matching between the both curves. And also, using this curve, we can show this anti-phasing distribution of precipitation between the West South America and eastern part of South America. Then we went to the models to try to understand how the climate and how the circulation were in this two period, the MCA and also the LEA. And when you use this, we really show the intensification of the transport winds from the Pacific region to the Indo-Pacific, and with less precipitation in this region recorded in a lot of our marine and our speleothems records, with more precipitation that I will show with you, to you using the lacustrine system. And when you go to the LEA, we have the opposite records. More precipitation in the Western Amazon and low precipitation linked to densification of the monsoon during the LEA that we find in different our records. And also this is published by Bird et al. In 2011. They share the same things, more precipitation during the LEA and dry conditions in the MCA. All this record in South America show the opposite phase between the two periods. And for the end, muchísimas gracias.